Well, hello, everyone, and welcome to another episode with your girl, Audrey. So let's see, just trying to put the finishing touches up on some things. So before we get into today's live, I just all of a sudden decided to go live. Had an awesome meeting with an awesome person. So I was like, hey, Steven, is it Martha or Martha? We are about to get into, so today is graphing linear equations. So this was actually a request by one of my viewers. And I said, you know what? I will put it together. But then I was kind of doing a little bit of cleaning. And let me see if I can get this shadow off of you guys. All right. So I was doing a little bit of cleaning and I found one of my old notes when I was a classroom teacher. So I said, well, wait, I'm about to do graphing linear equations, right? So one of the two things that we need is slope. And of course, the other thing that we need is the y-intercept. So I said, you know what? Let me take a look at this. And I found my old notes. Okay, so when we're looking for slope, otherwise known as the rate of change, basically slope is the measure of steepness of a line. So everyone knows it as rise over run. So if I may, I'm going to add to my notes here. So rise, you're either going to go up and down. Your run, you're either going to go left or right. And a lot of people will know it as the change of y over the change of x's. Or some people will say the difference of your y's over the difference of your x's. So in order for you to find delta, which means change, we can find it one of two ways. So we can find it if we're looking at it algebraically. We can find it basically looking at the difference of the y, so y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or you can do y sub 1 minus y sub 2 over x sub 1 over x sub 2. The main thing is your y's are going to be in the numerator, your x's are in the denominator. No matter if you want to start with the second version or the first version, you have to keep the same pattern. All right? You'll get an answer, but you'll probably get a wrong answer because you went a different pattern. So if you're going to start with the second y, that means you have to start with the second x. And the same here. If you start with the first y's, that means you have to start with the first set of x's. So, as we're taking a look, as I said, we can find this basically four different ways. We can look at it algebraically. We can look at it graphically. We can look at it numerically in a table, as well as we can look at it verbally, okay, just pulling information out. So what we're going to actually take a look at is not so much the calculations of the y's, but actually how that rise over run really works as a graph. All right, so can you post the notes? Oh, so glad that you said that because I'm actually thinking about selling these bad boys, okay? Because I have a whole, like when I say a bookcase full of these bad boys, I used to have like 4 classes and each class will have their own notebook. So a friend of mine, Lynette, she says, why don't you call it Audrey's Notes? Just like Cliff Notes, but I'm not Cliff, I'm Audrey. So these are some things. So obviously you can either screenshot and take what you want, or because I have a whole bunch of them, so I'm actually going to look at it. So if you think it's a good idea, oh, J-Mart, that would be such a good business. Okay. All right. No, I do not know how to do that. Abs. So sorry. Okay. So If we're looking at it graphically, remember, it's going to be your rise over the run. So you also have like some kind of starting point. So for this instant, let me zoom in onto the graph so you can really see it. So for this instant, we have 2 points. We have this point here at 0, 3, and we have this point here at 2, 0. Okay, so we're supposed to be counting by ones. So knowing I need to get from one point to the other. So in order for me to get to my slope, it doesn't matter which point you start with. So if I start down here, I want to know how do I get from this point to this point? And I like to think of like, say, city blocks. So you can't go through someone's house in order to get to, say, your friend's house. You want to start at one place and you want to go to the other. So if I start here, I have to go up 1, 2, 3 city blocks and then go to the left 1, 2 blocks. So if I go up, I'm going into the positive direction. So that's why we have a positive 3 here. If I go to the left, we went to the left 2, that's why it's a negative 2. Anything to the left is negative, anything down is negative. Anything up is positive, anything to the right is positive. So my slope, my rise, is going up 3, so positive 3, and to the left 2 over negative 2. Now I can also go the other way. If I wanted to start at this point 0, 3, I could go down 1, 2, 3. That's why there's a negative 3 here. And then go to the right 1, 2. That's why this positive 2 is here. So my slope could be negative 3 over positive 2. So if you take a look, I had both of those results written. Both of these are going to represent a negative slope. All right, so both of them are going to represent a negative slope. So what we can do is we have just one, not both, but one of them is going to be negative. Okay, so once one of them is negative, we got a negative slope. If both the numerator and the denominator is negative, that means we have a positive slope, because a negative divided by a negative will give me a positive. All right, so this is just the whole gist. So if you think of, like, say, hey, Audrey, I would love to get a copy of these notes, just DM me, and we'll see if this is something that I need to do. But let's get back to it. Okay, can I explain that? No, I can't. Okay, so rise over run, that's basically it. All right. So can you explain graphing quadratic functions in factor form? Okay, right now I'm explaining graphing linear equations. Okay, actually I'm doing the quadratic tomorrow, because originally I wasn't planning on coming here at all. All right, so as we take a look, if we can remember our equation of the line, so that's y equals mx plus b, okay? Your m is your slope, your b is your y-intercept, and it's also known as your starting point. So that's where you start on the graph. So you either can have it in what's called slope-intercept form, or you can have what's called standard form. So that's your 8x plus ax plus by equals c. And what you will do if you have it in standard form, you can use the x or the y-intercepts. Okay, so if you use the x and the y-intercepts, you'll be ready to rock and roll. Hello, Melissa, how are you? All right, so now, if we have our first equation, So let's say it is, and since we're looking at functions, I'm going to try to remember my f of x. So f of x equals negative 2x minus 3. Okay. So a lot of people will say, all right, well, I might need some points. So right away, people will go right into a table. And say, I can use the traditional values of, say, negative 2, negative 1, 0, 1, and 2. So if I have my expression here, so negative 2x minus 3, I'm basically substituting these x values into this expression for x. So we have negative 2 times our x minus 3, and our x value is going to equal negative 2. So now I can really figure it out. Negative 2 times negative 2, that will give me a positive 4. And 4 minus 3, that'll give me a 1. So the order pair for the first point that I have here is negative 2, 1. So now I'm going to do the same thing for each of these. So I have negative 2. Just need to move it over a little bit. So I substitute the negative 1 for the x. So now I have negative 2 times negative 1, and negative times a negative, that gives me a positive. And then minus 3. So 2 minus 3, that gives me a negative 1. So the order pair here is negative 1, negative 1. Same thing for 0. So we kind of did this a little bit yesterday for those that were here. I'm just going to start it off on all of those. Okay, so we plug our 0 in. So here, negative 2 times 0, that gives me 0. And 0 minus 3, that gives me a negative 3. If I plug in a 1, negative 2 times 1 gives me a negative 2. Negative 2 minus 3, that gives me a negative 5. And lastly, we plug in a 2. So negative 2 times 2 gives me a negative 4. And negative 4 minus 3, that gives me a negative 7. Okay, so we just basically found our slopes. So we found our points that's going to be associated with this line. So since we have a couple negatives, mostly positives, and it looks like the lowest we go is a negative 7, so we're probably going to need to come all the way down here. Okay, we only have like one positive number, so I'm going to put it up here. So my y values always go up and down, and my x values go left and right. So this will be 1, 2, 3, 4, 5, 6, 7, 8. We got 1, 2, negative 1, negative 2, negative 3, negative 4. Okay, negative 1, negative 2, negative 3, negative 4, -5. I like to make my 5s a little larger. 10. So you can see it a lot better. And this is a 1 and 2. Okay? So now, okay, good. So, taking a look at this, we have our order pairs. So the one order pair we have at -2, 1. So here's my -2. I'm going up 1, making my point. Then we have -1 to -1. That's this point right here. Then we have 0, -3. That's this point right here. Then we have 1, -5. So that's this point right here. And then we have 2, -7. All right. So with this, we can go ahead and draw our line. Okay, so this is our line for that expression. Now, that's one way of doing it. As you can tell, it does take you quite a while. But if you have your equation, which we do, in that slope-intercept form, all we have to do is identify and then plug in. So this is what I mean. So I noticed that, as I said over here, that my slope is basically the coefficient of my x. So the slope in this case is a -2. It's a whole number. So anytime it's a -2 or a whole number, it's really going to be -2 over 1 because we want to get that rise over run. So when we do that, we have our b. Okay, our b is our y-intercept. It's our starting point. So since that is a -3, okay, that minus sign acts as a negative, this is where you start. And this is where you start on the y-axis. Hence the name y-intercept. So a lot of people are always like, oh, I don't know where to start. You always start wherever your constant is. If your constant, it doesn't have an x or a y associated with it, and it's already solved in y, like it's in this slope-intercept form, your constant, your b, is where you start on the y-axis. So if I start here at -3, then from this point, you don't go back to 0. From this point, the y-intercept, you're looking at your slope. And like I said, your slope is the same as saying -2 over 1. So that means I can go down 1, 2, and over to the right 1. Going down takes care of the negative. You're not putting the negative in both the numerator and the denominator. It's just in the numerator. So here I am at -3. I go down 1, 2, and since that's a positive 1, I go to the right 1. And you have those 2 points. If you want to draw another point below, you just follow the pattern of the slope again. You go down 1, 2, over to the right 1. Okay, go down 1, 2, over to the right 1. Okay, we didn't even graph this point, but because we followed with the same pattern going down 2 to the right 1, we were able to graph that point. Now, if you ever feel that you don't have enough room down below, as some graphs will, we can follow the pattern going the other direction. If I started here at my y-intercept and my slope was -2 over 1, I can switch that to a +2 over -1. When you're dealing with the negative slope, only one of those two numbers need to be used. Okay? So if I'm starting here at -3, I can go up to 1, 2, and over to the left, because it's a -1, right here. Oh, that point's there. Go up to 1, 2, over to the right, 1. If I want to go 1, 2, and over 1, that'll be the other point that's on that line. All right? Okay. It's like, can I plug in any number into X? Yes, you can. If they don't give you a list for X's, you can. But you don't want to get too crazy, because then you don't want your graph to look all over the place. Okay? Normally, if they don't give me anything, I usually go with two numbers that are negative, a 0, and two numbers that are positive. If I'm noticing I'm multiplying by 3, my X values could be multiples of 3, so I can get a nice clean elimination. So I can solve for my numbers a lot quicker. All right. Okay. So instead of constantly plugging in, we just need two things. Okay. We need a slope. Okay, so we need a slope and we need a y-intercept. Those are the only two things that we really need so we can graph a linear equation. All right, so let's try another number. So we got my example. And let's say we have f of x is equal to 1/2. You're probably like, what? It's okay. Minus 5. Okay, you're welcome. So why did you use -2 to start with? Why did I use -2 to start with? What do you mean? Oh, for the x values? Because I just wanted like two numbers for the negatives to be represented, a 0, and then two numbers for the positive. So I just picked 5 numbers. Okay. And then plus, since this was leading, my coefficient was a -2, it'll be easy for me to navigate, so I won't have any decimals or anything. Okay. All right. So if we are starting with our function of 1/2 x minus 5, so how do you know what numbers to pick? You just pick them. You pick them and see which ones come out with a whole number. Yep, just pick the numbers. If they don't give you any numbers, just pick a number. So here, okay, we have f of x is equal to 1/2 x minus 5. All right, so now I'm not going to do the table. I'm going to go right into basically solving or graphing my equations. The reason why is because I see the two things that I need. Okay? So the two things that I need are my x-intercept and my y-intercept. So my x-intercept and my slope. I think I said y-intercept. I meant my slope. Okay. So now, I start with my y-intercept. Okay, my y-intercept is a -5. So that's where my first point goes on the y-axis. Now, from this point, I'm going to look at my slope. My slope is 1/2. So that means I'm going to go up 1 and to the right 2. So I go up 1 to the right 2. Right. Up 1, 1, 2. Okay. Hey, Leanne. Sure. So, okay. Tis light. Tis light. All right. Is it too light? Are you a math teacher? Yes, I am. I used to teach in a classroom. Now I have my own online tutoring business. So I tutor students from all around the world. So I tutor them in Nairobi, Kenya, Cairo, Egypt, all throughout the United States, California, Florida, Texas, Washington State, Maryland, Virginia. Where else am I missing? Both Carolinas, Massachusetts, Pennsylvania, and I feel like I'm missing something. Georgia. There we go. Yep, and I was in Ohio as well. Yes. All right. So, once you get your points, you can go ahead and just draw your line. So there's times that you don't even need to have your table of contents to make an equation on the line. Once you know what the slope is, once you know what the y-intercept is, that's all you're doing. You always start with your y-intercept. So it's a -5, that's where that first point went. Then my slope tells me the direction to go to get the next point. So since it's already a fraction, rise over run, if I may show you my old notes, rise over run is a fraction. Okay? So you go rise, that means you're either going up or down, and your run, you're either going left or right. So from this point, I can go up 1 and to the right 2. Okay, so I can go up 1 to the right 2. And if I want to keep going, up 1 to the right 2. And that's how I can get my gradient, my steepness. Okay. All right, good. You're doing this right now? Awesome. All right. Okay, hey Lucy. So this is the main thing. This is all you gotta do. It's like, so let's see. So if I give you, let's give you one more just to make sure you're good. I'm going to squeeze it down here. So I'm going to say example. So I'm going to say the h of x is equal to -1/4 x plus 3. Okay. All right. To get negative values for rise over run. So now, if we take a look, it's in slope-intercept form, so I don't have to do any solving. We can kind of do here. So we got here. We're starting at 3. So I come here. Okay, so you have 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 2, 3. All right. This is our x-axis. This is our y-axis. All right. Let's see. Does it make a difference if it's h of x or f of x? No, it doesn't. The h and the f's are just basically telling you what are the names of the function. That's all it is. You could have f of x, you can have g of x, h of x, p of x, not m of x. I've actually seen z of x. Okay, so all you're doing is just naming the function. Okay, good question. Okay, so where would I start? Looking at an equation. Where would I start? What will be my starting point? And remember, question marks. Okay. So Leanne's saying 3. Pretty 170 saying the y-intercept. Dolly's saying at 3. So are we assuming the 3 on the y-axis? So is it a combination of these two ladies' answer and Pretty's answer? Yes. Okay. Yes, and positive. Yes. Good. All right. So that means if I start here at 0, I need to come up to the constant, which is positive 3, put my first point there. So now I'm coming to the slope. The slope is a -1/4. So I can go down 1 to the right 2. So that's 1, 2, 3, 4. Okay. Now, if I wanted to, I could make this a +1 over a -4. So that means I would go up 1 over 1, 2, 3, 4. Notice what happens to those green points. Is the first number of the x-axis and the second numbers for the y-axis? Yes, it is. So the first number, okay. So this is my y's, and the 4 is my x's. So it's always the change of y's, coming back here, rise over runs, the change of y's over change of x's. Okay, change of y's over change of x. And then right here, boom, you got your line. Nice and neat. Okay, so rise is your y's, run is your x's. Yes. So does the placement of the points change when changing it to 1, -4? Yes, because if I'm going to start here at 3, if I go up 1 and over to the left 4, it's going to be different when I start here at 3 and I go down 1 to the right 4. The points are going to be on the same line, but yes, they're going to be at different spots. Or does it change direction? What do you mean, does it change direction? What, the slope? Okay, they're not changing the slope, because the slope is still going to be negative. Notice as I look at it from left to right, it's going downward. Okay. The left or right? No, it doesn't change the left or right. because your slope of the line will still be the same. It'll still be negative and going downward. Okay. All right. So now, how are we feeling? So that's when your equation's in slope-intercept form. Left negative, right positive. Up positive, down negative. Yes. Okay. X equals opposite B. No. Well, so that's in slope-intercept form. So what happens if we kind of change it up a little bit? So instead of slope-intercept form, oops, try to get that clear, okay? So instead of slope-intercept form, we have what's called standard form. So ax plus by equals c. So as recommended, in order to graph lines of standard form, you need to look at their intercepts. You have x equals 0, and you have 0, comma 1. Okay, so x comma 0, keep saying equals, and 0, comma y. Okay? So let's fold this up and do a little bit of shrinkage. All right, so let's say we have we have 2x plus 5y equals 10. Okay? So we have 2x plus 5y equals 10. Now, there are some teachers that would say, okay, we need for you to solve that and put it in slope-intercept form, which we just did, that y equals mx plus b. That's fine. You could do that. But you can also use your intercepts. So I'm going to look at our x-intercept, and then we're going to look at our y-intercept, and we're going to plot those points. All right, so we're using this original equation, and we are going to substitute the 0 for wherever we see a y value. So that means we have 2x plus 5 times a number equals 10. Now, the number in this case is supposed to be replacing y with the 0. So now we have 2x is equal 10. All right. So what we should do is divide both sides by 2. So when we do that, 2 divided by 2 gives me 1. So 1x and x, same thing, okay? Now, 10 divided by 2, that gives me 5. So it's just like what Peter said, okay? I think he was just like, yes, Ice Spice, good. So it's just like what Peter was mentioning, that when we plug in a 0, but this is what happens. We get a 5 out, not a 2. Okay, because we had to divide by 2, so 10 divided by 2 gave us the 5. Okay. So now we can do the same thing, but this time we're going to let our x value equal 0. So if we copy the same equation, I'm going to put a 0 for the x. So 2 times 0, that will just give me 0. And we don't need the 0 because we don't need the placeholder. But we bring down the 5y equals 10. Then here, we're going to divide both sides by 5. 5 divided by 5 will give me 1. So 1y. And then 10 divided by 5 gives me 2. So my order pair for this one is going to be 0. No. Did I screw up? I think I did. Yeah, I did. I was like, I feel something felt wrong. Did anyone catch it? No one catched it? Okay, my x value was 5. See, I'm half asleep, guys. I've been working all day. Not like you guys haven't been working all day either. But we just get so into the mode because this is supposed to be 0 and this is supposed to be 2. Now we're cooking with gas. Okay. So remember, it's my x, then my y. My x we substitute in for 0. We got a y equals, so that's why that's 2. This one, my y was 0, and we found the x. So it's supposed to be 5, 0. All right. Okay. So now we have our 2 points. You're probably saying, well, shouldn't we have more than 2? You can have more than 2. That's perfectly fine. But we don't really need that many. If it's in standard form, you can just find the intercepts. All right? If you feel like it, you can find the intercepts. And then you're just going to graph the intercepts. Mm-hmm. 0, 5, 0, 2. Okay, this will be enough. Okay, so here's my y values. Here's my x values. So you have 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. All right. So we have a point, 5, 0. So my x value starting here at the origin, that means I go over to the right 5 and I don't go up or down. So that's where that point 5, 0 is. The other point is 0, 2. Starting at the origin, I don't go left or right because it's a 0, but I go up 2. Okay. So now that I have my 2 points, I can draw my temporary line. And voila, there is your graph. Okay. All right, so I plotted 5, 0, then I plotted 2, 0, 2, And then I just draw my line. Okay. All right. How are we feeling? Okay. Hey, Lynette. How are we feeling? Good? Good. Good, good, good. Okay. So, like I mentioned, all right, you need two things in order to graph a linear equation. So, we can have our refreshers with the slope. Okay, so we have a rise over run. Okay, and we're looking at it more of a graphically situation. So we're really hitting on the rise over run. And the other thing that you need is your y-intercept. Where is it going to cross the y-axis? So if we come over here, it's always going to be your constant. This is where you start. Okay, so if in slope-intercept form, that means you have your f of x or you have your h of x like we have down here. All right. No matter what, excuse me, you're going to start at your y-intercept, the constant that doesn't have an x or a y next to it. Then you're going to use your slope to graph the next line. Okay. I'm a special ed teacher and go with my 9th grade students to Algebra 1. Love how you teach. Oh, thank you. Yes, break it on down step by step. Trust me. I don't know why a lot of kids struggle with slope. Don't know why, but it's a huge thing. But yet they can sit there and, calculate and factor. But when it comes to finding the rate of change, the struggle is real. And I think it's because their multiplication is not as strong, okay? They do everything, and I mean everything, through this thing called a calculator. But they don't really understand that multiplication is basically fast addition, all right? If they can get their multiplication facts solid, they will actually do pretty well, all right? So let's do... Oh, thank you, Jack, for sharing the live. I appreciate it. So as I'm setting up the next one, I'm going to try to do maybe 2 more because then I have to get myself ready for my next client. But I just wanted to come on here because one of my clients was working on this today and the struggle was real. All right. So, but I know there's a lot of people that are probably saying, well, hey, Miss Audrey, I could easily just solve this for slope-intercept form and just went ahead and graph it. That's awesome. But there are going to be times that you're going to deal with larger numbers. Okay, these are not that large of numbers. But there's going to be times that you're actually trying to find maybe like a combination, like say they always do one with children's tickets and adult tickets, and so many people, like system of equations. When you get into system of equations and you're dealing with larger numbers, working with the with the intercepts will make your life so much easier. All right. So while you guys are working on getting things set up for the next one, if you can go ahead and tap your screen, I would greatly appreciate it. See if we can get up to at least 5K. That will be amazing. All right, so we got like 2 more. All right, so we did that one. Let's do this. So x plus 12 is equal to 6y. I have to do it like this. Okay. Thank you, thank you, thank you. Appreciate it. Okay. So I'll see if I can zoom in just a hair. the intercepts here. And let's see if I don't screw up this time. This is why we don't do math in pen. Well, you know, feeling a little rebellious. All right. Well, thank you. Thank you so much for the tapping. I greatly appreciate it. But here is the next one. So we have x plus 12 is equal to 6y. Okay? And we are going to use, obviously, this is not in slope-intercept form. We could put it in slope-intercept form, okay? But let's see if we can use the intercepts. See if that will kind of help us out a little bit. So for my x-intercept, this is when my y value is equal to 0. So I'm going to take my equation. I got my x plus 12 is equal to 6, and I'm making my y equal 0. All right. So once I substitute that 0, 6 times 0, that will give me 0. So we have x plus 12 is equal to 0. What do I need to do to get x by itself? Put in the chat. What do you think I would need to do to get x by itself? All right, pretty saying subtracting 12 on both sides, minus 12, move to the other side. Yes, Mateo. Sweet Kelly, subtract 12 on both sides, subtract 12, subtract 12. The subtraction property of equality. Ooh, look at you, bundles. Being all fancy. So, since, yes, we're going to do that on both sides. Not divide, but we have a plus 12. So we always want to do the inverse, the opposite. So we're going to minus 12 on both sides. So positive 12 and negative 12, they cancel out. And this gives us x equals 0 minus 12 gives me a negative 12. Okay. So we found the x-intercept. Let's make sure Audrey does it right this time. So negative 12, comma, 0. So that's going to be my x-intercept. Now, I need to do it with the y-intercept. So this is when my x value is equal to 0. So I'm going to rewrite the equation. You got your x, but instead of an x, it should be a 0. Let me make that red. So we have 0 plus 12 equals 6y. Okay. 0 plus 12, that gives me 12. 12 equals 6y. What do I need to do to isolate my y? Hey, Ivy, how are you? And, and you just came on TikTok and you're like, all right, I'm going to watch some foolishness. Here's Audrey. Here's Miss Audrey torturing the children of the world again. Divide by 6, divide by 6, divide by 6 on both sides. I love that. So we are dividing the 6 on both sides. Yes? I'm doing a little short DPE. Look at you. So 12 divided by 6 will give me 2. And 2 equals y. So now, bundles of blessings. What is the property that we need to use in order to go y equals 2? You can put the abbreviation. I'll take that. So we did the division property of equality to get my 2 equals y. How do I flip it for y equals 2? Everybody's like, But I appreciate everyone not leaving. Because usually when I throw a question like that, people are like, it's not commutative. I'll give you a hint. It begins with a R. You go ahead and tap while you think. Tap while you think. It's always good to have a little movement. Hello, Alex. You don't know? Okay. It's called the reflexive property. Okay, so the reflexive property of equality. Okay, so we got the reflexive. Because I know most of us like to have the y's on the left-hand side. And especially when you get into geometry and you're doing proofing, remember your results should always look like, your solution should always look like what you're trying to find. So if you do 2 equals y, you got to finish it out with the reflexive property to make it y equals 2. Oh, not a problem. That's why we're here. Hello, Michael. All right. So now, my order pair for this is going to be 0, 2. All right. So now I have a -12, 0, and I have a 0, 2. So if I am going to draw, I'm going to see if I can do it right underneath. I'm going to see if I can, whoa, got a little crazy over here. See if I can angle it a bit so everyone can get it. So since it's going to be -12, I'm going to see if I can bring my graph all the way over here. And it doesn't have to be so tall, but it does need to have, I think this is enough spacage. If not, we can always extend. Okay, so here, 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 and here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, she just squeaked that in there. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4. Okay, so this is a 1. This is a 1. This is a -1. That's a -1. All right. So our first point is going to be at -12, 0. So if I start at the origin, I come all the way to -12. So that's this point right here. And then the other point is at 0, 2. So start at the origin. I come up to 2, make that point right there. I got my 2 points. And sometimes they will ask you, like, can you just sketch? Okay, that means it doesn't have to be too exact. Okay, if they ask you to sketch anything. All right, so bada boom, bada bing. And let me shrink this bad boy so everyone can see. Okay. You're late for class. Where's your note? Or I could be one of those teachers that are like, you weren't here the whole time? Oh, okay. The ones that just sneak on in the back door. Oh, I remember those days. People be at the window like, psst, open the door. Come open the door. And all you see is someone just waving with the fingers. And you're just like, boy, just get in this room. We ain't got time for you to go get notes and stuff. It's craziness. Oh my goodness. All right. So, I need to buck up. So I am going to give you one problem. I'm going to see what you can do, at least convert it. Okay. Tell me what my x-intercept is and tell me what my y-intercept is. And then we can graph it together. Okay. So, last example for the day. Or you could be one of those kids that come late and their mom will stop off at McDonald's or Chick-fil-A and they'll come in there with a big bag of stuff. Just smelling up the room. Ugh, that was annoying. Do you have any videos for graphing inequalities? I think I do. If anything, check my YouTube. If there isn't one, because I know I did some, but I'm not sure if I did it for tutoring or if I did it for TikTok. I'm telling you, this is how my life is. I mean, like, this is how my life is right now. I'm like, okay, did I have clothes when I walk out this morning? Yes? Awesome. Win! But if I don't, I can see if I can do inequalities. Okay, so check my YouTube. It's Audrey Codner, ACG Math Tutoring. And if there isn't one there, I'll see if I can add that to my repertoire. Okay. All right, let me zoom in a little bit more so you guys can see. It's like everything's all kinds of wacky patacky. There we go. Much better. Okay, tell me what my x-intercept and my y-intercepts are. Oh, Miss Libra. Hey. Libra powers. I'm a September Libra. Can you tell? Oh, can you tell? Detail oriented. Yep, it's me. Hey, Chocolate Unicorn. How are you? Oh, you're October Libra. Okay. It's almost like it doesn't even matter. Like, we're always balanced. We're always like, okay, let me hear both sides of the situation before I pop off. Now, don't put your answers don't put your answers down just yet. Just go ahead and calculate your x-intercept and your y-intercept. Okay, probably like in another minute and 10 seconds, I'll ask you to reveal your answers. Okay. Oh, it's in my cancer. Oh, no problems. You didn't know, Michael. You didn't know. I was a little slow with it. I'm sorry. I should apologize to you because I should have said that sooner. And just like life, time is flying. Got 10 minutes, 10-minute warning, or 10-second warning, 10 minutes. Okay, go ahead and put your answers in. Hello, Michael C. 99. Welcome on in. Oh, Gio. Hello, Gio. I haven't seen that name in a while. Okay, so we have our -8 and we have a 4. We have 0, 4, -8, 0. Ivy's like, I don't know. And watch, she'll be right. Ivy. I don't know. I think it's the right answer. Hello, free coin TikTok coins. Such a pleasure for you being here. Between you and, who's the other guy? Spotify. Like, I feel like my lives are empty if I don't see your names. It's hilarious. Hello, Sandra. Okay, just 2 people? I mean, I do take question marks. So if you're just like, I don't want to put my answer up there, you can put a question mark. I'll do that. Okay, bundles of blessings, saying 0 and -4, and -8 and 0. Okay. Okay. Hold on. Okay, Michael R, we got 0, 4, and +8 and 0. Cool kid. Hey, cool kid. Welcome on in. Okay, so while we're waiting, go ahead and tap away. Tap away, tap away. If we can get to 6K, that'll be awesome. Because I know this was like a last minute type thing. We weren't really all with it. Thank you, bundles. Okay. Okay, McKenz, how you doing? Mackenzie's. Maxie's? Okay. Can at least substitute. Okay, so cool kids saying 0, 4, and 8 and 0. Okay, so we got the battles between the positive and the negatives. Okay. All right. So if I'm plugging in, I'm plugging in 0 for my y's. So I have 2 times the 0 equals -x plus 8. So I'm putting the 0 in for my y's. So we know that 2 times 0, that will give me 0. And then we have negative x plus 8. So now, with that being said, we need to subtract 8 on both sides. So when we do that, the 8's will cancel out on the right-hand side. And then we have 0 minus 8. Okay, so that will give us a negative 8. But here's the thing. There is a negative sign in front of that x. Okay, so that means we have to divide both sides by -1 because we want to get x by itself, not negative x. So this negative and that -1 will cancel out. A negative divided by a negative will give me a positive. So we're saying that my 8 is going to be positive, comma, 0. Okay, yes. A lot of people generally miss it. They always miss that minus sign that needs to come with the x. Okay, so it's a common mistake. Okay, so now we have a 0 for the x. So we have our 2y is equal to negative, and we're going to put a 0 there, plus 8. And we know that 0 is neither positive nor negative. So what comes down is my 2y is equal to 8. So now I have to divide both sides by 2, and we got y is equal to 4. So the order pair here is going to be 0, comma, 4. All right. So if my x is going to be an 8, so, and then we got plus 4. So I'm going to kind of stick it right about here. I'm going to try to get about here. And then since we don't have any to negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we can do it this way. I'm going to stick about here. So that's my 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. And we don't have any negatives, so I don't really have to worry about them. Okay, so my 5s are a little bit longer, so it's easier for me to find them. So if I'm doing 8, 0, starting here at my origin, I'm going to do this. Go over to 8. And my y-intercept is 0, 4, starting at 0, and I'm going up 4. So then I'm using those 2 intercepts to draw my line. Do, and do. Okay. So the negative is just omitted. Yes, because when you divide, when you get here, remember it was a negative x that needed to come down. So when we divided both sides by -1, a negative divided by a negative gives me a positive. Okay. So that's why that negative just disappears. Okay. All right, are we good? All right, I hope so, because I have to go soon. Any other questions? The negative in front of 0. Yes, well, think about it. 0 is neither positive nor negative. Okay, so anything times 0 is going to give you 0. So this 0 is gone, and I don't need to bring the 0 down because 0 is a placeholder. And I don't need for it to hold a place because I still have this plus 8 that needs to come down, this positive 8. So since you have your 0 times anything will give me 0, and 0 plus 8 will give me 8. Yeah, so I didn't have to bring it down. When will I post this? I'm going to try to post it this evening. Yeah, I'm going to try to post it this evening. Because I have a client in about 8 minutes. Just about 8 minutes, okay? All right, so here's my shameless plugs. Now, real quick, as you can see, if you like the styling of my notebook, I designed this, right? I got sick and tired of my students not having their own math notebook. So I designed it. So they can have their formulas on one side, they can have their steps on the other side. Let me see if I can move stuff back. So if you need to take a screenshot, you can. Okay, let me know if you already got a screenshot. This is Algebra 1. This is like pre-algebra, Algebra 1. Algebra 1, I want to say first semester. Yeah. Okay, thank you, Code. Okay, you helped me pass the college algebra. Oh, so good. Not a problem. Oh, I'm so glad that you passed it. So, all right, ready for the next page? Not a problem. So if you ever want to get a math notebook and you want to purchase it, it is on Amazon. If you want, you can click my picture in the profile is the website, and it will actually take you directly to Amazon so you can order it. And it's not just notes. Like, yes, I have notes in here. I cut bits and pieces of worksheets. I do a lot of construction, and I write rather large because I'm doing a lot of presentations from here. But if you're not strong with your multiplications, I have factor sheets from 1 all the way up to 200. Then I also have the rules of integers, okay, from addition, subtraction, multiplication, and division, as well as the order of operations and the properties of exponents. And then we also worked a little bit with the linear. Here's slope or rate of change. Here is standard form. Here's slope-intercept form. Okay, so it just kind of gives you those reminders and some of the equations to help you figure things out, especially for geometry, a little bit of quadratics. Then we have a little bit of trig with the Pythagorean theorem, SOHCAHTOA, okay, and then also volume, and then surface area, area of the sector, arc length. I did that for Pi Day. So if you want to see the video of what I've done with Pi Day, you can go ahead and go to my YouTube channel, Audrey Codner, ACG Math Tutoring, and this is the unit circle. In addition to it, I usually have some brain break activities just to help you refocus, something more than just doodling. You could just do some coloring with your color pens and all that. All right, so that is my math notebook. We're going to be working on some of these lovely things shortly. But again, if you want to, you can go ahead and subscribe. I will be putting today's video on, I want to say probably roughly maybe 10 o'clock this evening, Eastern Standard Time. It should be up. And I usually go live Tuesdays at 8:30. I just had a cancellation, so I decided to jump on here. Wednesdays at 1 o'clock, especially, and also Thursdays at 1 o'clock. And I have to change my time on Sundays because I have a new student there, but I will try to do something during the weekend as well. All right. Do you have anything posted for graphing quadratic functions in factored form? You can check because I know I've done it, but I can't remember if I did it through TikTok or if that was a tutoring. But I'm definitely doing it tomorrow. Okay, I know I'm definitely doing quadratics tomorrow because I have most of it already situated. All right. Okay. All right, guys. Unfortunately, I have to jump off because I have to get myself ready for my tutoring session. Hopefully, okay, not a problem. Hopefully, I will see you guys tomorrow. So tomorrow evening at 8:30, I don't think I'm going to be on in the afternoon. No, I won't because I am jam-packed. All right, so I will take care. Oh, hey, Lisa. Yeah, just jumped on. I know, and I'm just jumping off. All right, so if you want the replay for today, it will be on sometime like around 10 p.m. It might be on a little earlier. It all depends on how we kind of upload it. You know, sometimes it takes forever. All right, guys, have a lovely day, and I'll see you guys tomorrow. Take care. Bye now.